Ever wondered if AI could craft a recipe that's not just edible, but inspired? What if a machine could generate dishes that balance flavor, technique, and creativity? Today, we're diving into a groundbreaking study that's redefining how language models understand the art of cooking, and why the answer lies in fine-tuning and custom tokenization. Let's start with the core challenge. Recipe generation isn't just about stringing words together. A functional recipe requires precise structure, ingredients, measurements, sequential steps, and that intangible cooking magic that makes a dish work. Traditional models, they struggle. Think of them as chefs who forget to add salt in the first step, or mix up the order of instructions. This study tackles that gap by retraining language models to grasp the nuances of culinary logic. The team tested 3 approaches: a large GPT-2 model, 774 million parameters, a smaller GPT-2, 124 million, and older recurrent models like LSTMs. Why? Because while bigger models have more parameters, they're also computationally heavy. The question was, can a smaller model with the right tweaks outperform its larger counterpart? Here's where the innovation shines. The researchers didn't just feed the models raw data. They fine-tuned their internal knowledge to prioritize recipe-specific logic. But here's the twist. They designed a custom tokenizer. Think of a tokenizer as the AI's dictionary. Standard tokenizers split words into fragments, but recipes demand precision. How do you keep 1 2-cup as a single unit? How do you distinguish ingredients from steps? The team added special tags like Inger Start and Next Inger, effectively teaching the AI, hey, this is where the list of ingredients begins. The results? Surprising. The large GPT-2 model improved by over 20% in BERTScore, a metric that measures semantic relevance. It's like the AI finally understands that sauté onions isn't just a random phrase but a critical step. Perplexity, a measure of how well the model predicts the next word, dropped by 69.8%. That means the AI is far better at avoiding nonsensical steps, like add sugar, then boil water, then add salt again. But here's the kicker. The smaller GPT-2 model outperformed traditional LSTMs. Why? Because fine-tuning and smart tokenization matter more than sheer size. It's like giving a skilled chef a better recipe book. Precision beats brute force. Of course, there's room for improvement. The models occasionally suggest unrealistic combinations, like 20 cloves of garlic for 1 person, or baking a fish at 500 degrees F for 3 hours. They also sometimes forget ingredients or add ones that weren't there. Think of it as a chef who's great at following a recipe, but might accidentally use salt instead of sugar. So what's next? Researchers are exploring ways to integrate real-world constraints, like dietary restrictions or ingredient availability, and even multimodal inputs. Imagine pointing your phone at a fridge full of veggies and getting a tailored recipe. This isn't just about cooking, it's about how AI can learn structure and nuance in human tasks. Whether it's recipes, instructions, or creative writing, the lessons here could revolutionize how machines generate complex, structured content. In the end, this study shows that AI is evolving from text generators to context-aware collaborators. But it also reminds us, even the best models need a dash of human oversight. After all, cooking isn't just about steps, it's about heart. Thanks for watching. Stay curious and keep exploring the intersection of tech and everyday life.